What we're running here is a proppant material, which is going to be analyzed on the right with a laser diffraction system and on the left with a dynamic image analysis system. The sample is the same sample that's being run through both systems. And the goal here is to show how a number-based technique, being the one on the left, a dynamic image analysis system, is a necessary complement to a laser diffraction system, which is a volume-based system, the system on the right. And what we will see is the fact that we do measure the larger particles, as you can see on the screen on the left, but it will be unable to measure the smaller particles due to the weakness in the scattering intensity of the smaller particles. And what I've noticed is there are definitely some small particles in there. If I convert this over to a volume weighted distribution, we'll start seeing some similarity in between what we're seeing here at about a D50 of 556, and here we're looking at somewhere in the 500s. So that's the first measurement. So as you can see here, we're already running 37,000 particles per ml, a total of 3,000 so far. And again, we're looking at a volume weighted distribution, comparing it to laser diffraction. But when you look at the Hydro Insight, we go to number weighted, we definitely see there's a large population of small particles. These are all these small particles that you see here. So let's take a pause and we'll come back to this. As you can see here on the laser diffraction system, we have a D50 of about 495. When we look at dynamic image analysis, we have a D50 of about 544. A little bit different. Not very surprising given that they are different techniques and the particles aren't completely round. If you look at the circularity, a majority of the circularity is, the mean circularity is about 0.73. So because the particles aren't perfectly round, there is going to be a little bit of an irregularity in size. So I think that's why you're going to see a slight difference in particle size, ECA diameter, equivalent circular diameter, of volume weighted from dynamic image analysis compared to laser diffraction. What is interesting though is in laser diffraction there is no scattering, no reporting of particles below the main peak, whereas when you look at the number weighted distribution for image analysis, there are a large number of particles in the smaller size range. Neither one is wrong. The reason is because of the volume weighted distribution, and the weak scattering intensity does not allow laser diffraction to see these particles. These particles are actually there. We can actually view them not only in the image, but we could also view them in the thumbnail images. So in the thumbnail images, yeah, there are going to be some doublets and triplets, but definitely we could see all these larger particles when they are singlets. They're definitely in the 500 micron range, 600, but definitely they are irregular in size. When we started looking at some of the smaller thumbnails, definitely found a couple of bits of fiber in there. It's a bit bizarre, but as you can see, there are definitely small particles in there in the sample. The fact that we actually had small particles and they were not seen by laser diffraction doesn't necessarily mean that they're not there. This is why this is a good complement to have image analysis as a complement to laser diffraction. With respect to the application that we're working on here, the vast amount of small particles is what was causing the rheological differences in the fracking material in the proppants. And the fact that they were using two techniques, sieving and laser diffraction, they could not see these small particles. This is why their viscosity was a bit irregular, and it's because they couldn't see these small particles. Therefore, a number weighted technique such as dynamic image analysis is a great complement for laser diffraction. I hope this helps. Thank you.